finally, let's cover question number 10 for today. So question number 10 reads, using the vertical line test, determine which graph represents a function. Okay, so I've described what a function does, but I'll describe in a little bit more detail about what the vertical line test helps us to do. Okay, so I've said that a function has a domain and a range. So a domain is basically all values of x that define our function. So what it means by define is that it produces a valid value, right? So it doesn't produce any undefined values, okay? So that's what a domain does, and we usually say it's x, okay? So our function is like a bridge between the domain and range. It takes a value of x within our domain, and it pops out a value in our range, which I'll say is f of x, okay? So the range is basically encapsulates all the possible values of our function that maps from the domain, okay? So in previous lessons, I have very much emphasized these two facts, that there's a domain and there's a range, right? But there's another property of functions that we need to define, okay? So another property of functions is that what we call one-to-one, all right? So that means that one value in our domain maps to a singular value to the range, okay? So with this restriction in mind, right, a function is then defined as a tool that maps one value to another, and that's the only mapping that it has. So for example, if a value of x within our domain maps to two values within our range, then we cannot define that the tool that maps them between each other to be a function. Okay, so how does this translate to what we look at on a graph? Okay, so we see here that we have four different options. We have A to be the sideways parabola, B to be a circle, C to be a vertical line on the axis, and D to be a cubic function. Okay, so as I described before, a function maps one value to another, one value from the domain to another, okay? So for example, if we were to have a value a in our domain, then the function is valid if it maps a to a value in our range, let's say b, and that's the only value that a maps to. Okay, so if A were to map to B and to, I guess, another value called C in the range, then it's not a function. So how does that translate to our graph? Well, we see here that on our graph, let's say, for example, actually, let me give you guys a valid graph first before we jump into these examples, okay? So if we were to have a graph here, and let's say that we have a line graph, so we have a line equation, right? Okay, so f of x equals mx plus whatever, okay? So this is our line equation here, and these are our axes. We see here that this is a valid function because one value of x maps to one value of y. So for example, if we were to have x1 here, it maps to a value called y1, right? And it only maps there, right? x1 doesn't map like to another value, right? That's not how our function works, as we can see by our graph, right? So for example, if we had like x2 over here, right? It maps to another value and only one value, and that is called y2, right? So x2 maps to y2, x1 maps to y1. x1 never maps to y2, right? If it did, it would not be a function. Okay, and this is where the vertical line test comes in, because it's a very simple test to evaluate whether or not your function is legitimate. So the vertical line test, basically, you take a line that is parallel to the y-axis, and you just put it through your graph. And if it only cuts through your graph once, then that your graph is a legitimate function. It represents a function. Okay, so let's take a look at our examples here, and let's see, using the vertical line test, which graph is a function and which one is not. Okay, so if we were to put a line through example A, So let me just draw a huge plot here, and I'll just plot everything on. Okay, let me make it black too. Whoops. Okay, so let's make a huge plot here. Let's move it over here. Okay. All right, so we have x and y. Okay. All right, so first we have a sideways parabola. So let's put this down here. All right, so if we were to put a vertical line through this, let me make it a thick line too. All right, whoops. So if we were to put a line through this, for example, so this is our vertical line test, right? Here we see here that our sideways parabola, our vertical line cuts through it 2 times. So you see here that every value of x actually maps to 2 different values. So we see here that value x1 maps to this value over here, and also it maps to this value over here. So this is not a valid function. Right? This graph is not a function. Okay? So let's repeat that with a circle. If we were to cut a line through this circle, for example, so let me get rid of this parabola here. So delete. Let me just delete this and delete this. All right. Sorry about this. All right. So if we were to have a circle, for example, let's put the circle here, and we were to cut our vertical line through it, we'd see here that our vertical line intercepts the graph at 2 points again. So this is not a legitimate function. This graph is not a function, right? Because we see here that one value of x in the domain maps to 2 values of y. So this is also not a function. What about a vertical line? Okay, so if we had a vertical line, let's say, oops, we have a vertical line like this, right? And if we were to put our vertical line through this graph, we see here that our graph infinitely intersects our graph, basically. So this is not a function. And we see here that there is only one value in our domain. There's only one value in our domain, which is wherever this vertical line intercepts the x-axis. We have this x value that maps infinitely to all values of y. So this is not a function either. Okay. So finally, we have a cubic function. So I'll just draw this cubic function real quick for you guys. And excuse my bad drawing. It's pretty hard to draw this cubic function, but I'll try my best. So there's a... Okay, sure. Cool. All right, so if we were to take a vertical line and put it through this function, this graph, we see it intersects once here. Let's try it again. It intersects once here. It intersects once here. So what does this tell us about our graph? It is indeed a function because one value of x maps to one value of y. Okay. So therefore, graph D represents a function. So the junior tutor went through everything that I explained. They described the vertical line test. They described what a function does. They gave us some examples of some functions. And then they evaluated what each of these graphs and which one is a function and which one is not. And by doing so, they came to the conclusion that only graph D is a function. So this is the correct solution. Good work and nice description. Okay. Cool. So that wraps up today's lesson. I covered 10 questions surrounding functions in algebra. But other than that, if you have any other issues or any problems with your algebra or mathematics, please submit them for OneClass. And I hope that you guys have a good afternoon, and I'll see you guys next time.